What happens when a region is shaped by fire, ice, and water, where every landscape is the result of millions of years of transformation? That is the nature of the Pacific Northwest. Here, ancient volcanoes, snow-covered peaks, and deep lakes form a terrain that is both dramatic and constantly evolving over time. Rainforests, waterfalls, and glaciers do not exist in isolation. They connect into a natural system where each element influences the others. Humans do not fully shape this land. They explore, adapt, and coexist with an environment that is always changing, yet follows its own patterns. What makes it unique is the diversity within a relatively compact space, from wet forests to dry plateaus, from rough coastlines to cold mountain peaks. So this region is not just a collection of landscapes, but a complex natural system where everything is in motion, while still maintaining overall balance. Smith Rock State Park is a place where stone looks as if it was raised upright with almost deliberate precision. Its pale cliffs, sharp spires, and dry carved canyon create a landscape that does not need great size to overwhelm the eye. It is one of the most recognizable images in Oregon, not because it is enormous, but because its forms are so exact. This entire place is an exposed edge of a vast ancient caldera formed by eruptions about 29.7 to 27.5 million years ago. Tuff and basalt built the original framework, and then a river cut deeply through the rock over immense spans of time, revealing walls that are almost vertical. That is why Smith Rock feels like a structure split open to expose everything inside. Its history is not simple either. The name Smith Rock is still debated, and the area did not officially join the Oregon State Park system until 1960. That shows its value was recognized gradually, not only through appearance, but through lasting significance. Smith Rock became famous across the United States as the birthplace of modern sport climbing. But what makes it even more remarkable is the way time, water, and stone work together to create a landscape that looks sculpted, yet is entirely real. Hoh Rainforest is an ecosystem where water acts as the architect. With average annual rainfall of about 11 feet, humidity remains so high that mosses, ferns, and epiphytic plants grow not only on the ground, but also across trunks, branches, and even decaying bark. The entire forest appears as a living mass, continuously sustained by water. What makes Hoh Rainforest unusual is not a single species of tree, but the way life occupies nearly every surface. Ancient trunks are almost completely covered in green, while light is trapped beneath the dense canopy, creating a dim, wet space with very little disturbance. Even sound is softened by the heavy foliage and thick moss, giving the forest an unusual depth of silence. The history of Hoh Rainforest is not the history of stone or construction, but of a living system that sustains itself over long periods of time. Fallen trunks do not end their role when they collapse. They become nurse logs, supporting the next generation that rises from their own decaying wood. Hoh Rainforest is therefore not simply a forest. It is a closed cycle in which water, wood, moss, and shadow combine to create the feeling of standing inside an ancient version of Earth that still survives in the present. Crater Lake is one of the few places on Earth where geology can be seen almost intact with the naked eye. About 7,700 years ago, an enormous eruption collapsed an ancient volcanic structure here and left behind a vast caldera. Over time, rain and snow filled that basin, creating the deepest lake in the United States at about 1,943 feet. What makes Crater Lake remarkable is not only its depth, but the way it reveals Earth's real power in a form that is easy to grasp. This is not a lake carved by a river or a glacier, but the depression left behind after a geological catastrophe. That is why the entire landscape feels both silent and extreme. The lake is fed almost entirely by rain and snow, with almost no large inflow carrying mud or sediment into it. Water can remain there for about 150 to 157 years, helping preserve an unusual level of clarity. That purity is what creates the deep, cobalt blue color that looks almost unreal. Crater Lake also carries unusual historical depth. For indigenous communities, this place was once considered sacred and tied to the memory of a major natural event. Later, it was protected as a national park in 1902, a reminder that the quiet beauty seen today was actually born from destruction. Mount Robson is the kind of summit where geological scale becomes almost absolute. Rising 12,972 feet, it stands out for its sheer faces and a mass that appears almost detached from the surrounding landscape. That shape alone creates a rare sense of pressure and dominance. What makes Mount Robson exceptional is not only its height, but its structure. Sedimentary layers were uplifted, folded, and clearly exposed across the mountain, revealing a tectonic history built over millions of years. Across that surface, permanent ice and glaciers keep carving and sharpening the ridges, giving the whole mountain a form that feels both massive and razor cold. Mount Robson is also known for generating cloud around its summit. Moist air is forced upward, meets the cold mass of the mountain, and condenses quickly, so the upper peak can appear and disappear within a short span of time. That phenomenon makes the mountain feel even more elusive and difficult to hold in view. Mount Robson is therefore not simply a high mountain. It is a place where tectonics, glaciation, and atmosphere can be seen acting together on a gigantic rock mass that is still being edited by time. Mount Rainier is the kind of mountain that makes the word landscape feel too small. It is an active stratovolcano rising about 14,410 feet. But what makes it unusual is not only its height. The entire mountain feels like a place where fire and ice still exist inside a structure that has never become completely stable. Mount Rainier's scale comes from a clear geological conflict. Volcanic forces built its massive body, while glaciers kept cutting and reshaping its surface over long periods of time. With 28 named glaciers, this mountain is not only tall, but heavy, sharp, and cold in a way that feels very different from an ordinary peak. Long before it was protected as a national park in 1899, this place had already been tied to indigenous communities for generations. They came here seasonally to hunt, gather berries, collect medicinal plants, and live with the water released by its immense ice mass. The old name, often understood as Mother of Waters, reflects that role clearly. But Mount Rainier is not only a landscape icon, it is one of the world's 16-decade volcanoes, meaning it has the potential to cause major disaster if it erupts. Beneath that enormous ice cover, this geological system has never truly fallen asleep. Mount Shuksan stands isolated as a complex metamorphic massif, where sharp peaks and hanging glaciers coexist along nearly vertical rock faces. However, this structure is not the product of volcanic activity, but the result of intense compression and uplift since the Paleozoic era, when ancient sediment layers were deeply transformed within Earth's crust. Dark rock bands interwoven with white snow and glacial meltwater create a distinctly geological palette. The shape of Mount Shuksan shifts with perspective, appearing as a sharp pyramid or a sheer vertical wall reflecting uneven tectonic forces and ancient glacial erosion. Hanging glaciers are not static. They slowly move, carving into the mountain and widening fractures over long periods. This ongoing process preserves its jagged structure instead of smoothing it out like many other mountain ranges. At the base, temperate vegetation abruptly stops at the boundary of permanent ice, marking a clear climatic division. Mount Shuksan, therefore, stands not just as a rock mass, but as a living record of geological history spanning hundreds of millions of years. Mount Hood is an active volcano, but what makes it stand out is not geology alone. Its shape is so clean and balanced that it almost looks unreal. Rising about 11,250 feet, it is the highest peak in Oregon and one of the most recognizable images in the entire Pacific Northwest. What makes Mount Hood unusual is the layering of heat and ice. Beneath it lies a volcanic system that is still alive. Above it remain long-lasting snowfields and 12 officially named glaciers. That combination gives the mountain both an almost perfect appearance and the sense that it has never become completely stable. Historically, Mount Hood did not begin as a tourist or climbing destination. Long before it was named in 1792, it already existed in the memory and traditions of indigenous communities as a force greater than human beings. Its present structure is only about 500,000 years old, extremely young on the time scale of Earth history. But Mount Hood's beauty always carries a warning. Its magma is highly viscous, which makes explosive eruptions more likely than gentle flows. For that reason, this is not just a visual icon, but a mountain that is still operating quietly beneath its surface. Painted Hills is a place where time does not sit inside a museum, but appears directly across the hillsides in bands of color. Red, yellow, brown, and black are visible there not because of beautiful light, but because the rocks and soils recorded environmental change across tens of millions of years. That is why the landscape is striking at first sight. It looks like painting, but its nature is entirely geological. Scientifically, Painted Hills preserves a sequence of ancient climates formed about 34 to 28 million years ago, when Earth was shifting from warmer, wetter conditions toward cooler and drier ones. Each color is a signal of a different environment. The red layers are linked to iron-rich soils formed in warm, humid conditions, while the paler, yellow layers reflect drier and cooler periods. What makes it unusual is that the color is not spread across the surface, but built into the structure of the rock itself. The dark bands are connected to manganese or ancient organic material, while the gray layers reflect fine sediments compacted over time. The more closely it is viewed, the more it resembles an exposed cross-section of climate history. Painted Hills is therefore not only beautiful, it shows that nature can turn volcanic ash, minerals, and time into a scientific record visible to the naked eye. Tamolitch Falls is a hydrological paradox where the river suddenly disappears into the earth, only to reappear in a mystical, cobalt-blue basalt basin. Once a magnificent waterfall, the water now flows underground through ancient lava tubes, creating an absolutely still surface. The surrounding basalt strata are the result of lava flows from 1,600 years ago, forming a complex underground drainage system. The brilliant blue color of the water isn't from chemicals, but from the depth and purity of water filtered through porous volcanic rock, creating a natural optical laboratory. The water temperature is consistently at freezing point, around 37.4 degrees Fahrenheit, challenging any biological invasion. The lake bed reveals geological fissures, creating a mysterious space with profound scientific and visual depth. Tamolitch Falls is a geological fortress where volcanology and hydrology script a narrative of rebirth. Ecola State Park stands as a geological fortress where the Pacific Ocean relentlessly carves its way into the basalt coastline. The basalt cliffs here rise over 200 feet, acting as a solid barrier against the brutal erosion caused by the powerful ocean waves and trade winds along the coast. The unique feature of this area lies in the hollowed-out geological structures, creating mysterious sea caves and solitary sea stacks far offshore, remnants of a lost continent that once extended far beyond the current coastline. The coastal rainforests cling to the top of the cliffs, constantly battling the salt-laden air and the strong trade winds, shaping twisted tree trunks that create a striking biological boundary between land and ocean. Ecola State Park is a natural fortress, preserving the raw, erosive power of the Pacific Ocean on volcanic basalt layers, an awe-inspiring testament to nature's resilience. Shannon Falls is the kind of waterfall that does not drop like a free vertical column, but spreads across granite that was smoothed by glaciers long before people ever saw it. At about 1,099 feet, it is the third highest waterfall in British Columbia, and the broad, steep, pale rock surface gives the flow a very unusual form. Instead of cutting deeply into the rock, it slides, fans out, and breaks into white bands. What makes Shannon Falls remarkable is not only its height, but the way the landscape was formed. Ancient glaciers scoured and polished the granite, leaving behind a broad rock face stable enough for water to flow over it for thousands of years without drastically deforming the underlying structure. That is why the falls feel both soft in motion and extremely hard in framework. The spray rising from the rock ledges creates a cool, wet microclimate around the base of the falls, enough to support dense moss and ferns on the stone surfaces. Here, water does not only flow, it also creates the living conditions for the organisms that cling to the rock. Shannon Falls is therefore not only visually beautiful, it clearly shows how glaciers, granite, and flowing water can work together to create a landscape that feels both graceful and weighted with geological time. Thor's Well is not famous because it is large, but because it makes the ocean look as if it is pouring into itself. It is a small, dark, round hole in the coastal rock, but when the waves arrive at exactly the right rhythm, water can be pulled downward and then blasted back upward like a reverse waterfall. Few landscapes make their moving mechanism this visible to the naked eye. The power of Thor's Well comes from the precise interaction of tide, wind direction, wave size, and the geometry of the rock cavity. Change only one of those factors, and the entire visual effect changes with it. That is why this place has no fixed form. It is a repeated performance that never looks exactly the same twice. One detail makes Thor's Well more unusual than many other coastal scenes. It can turn violent even without a storm. Near the peak of high tide, the water alone is strong enough to create surges and suction that are difficult to predict. That is why this place is often remembered as a visual icon, rather than a simple hole in the rock. Thor's Well shows that nature does not need enormous scale to be overwhelming. Sometimes a single empty space with the right geometry, placed in the right location, is enough to create a scene that is beautiful, unsettling, and almost impossible. North Cascades appears as the Alps of North America, with a dense concentration of glaciers and steep granite cliffs rising through the clouds. However, its structure is not simple, but formed from multiple ancient continental fragments compressed and uplifted through tectonic processes over hundreds of millions of years. Glaciers play a primary role in shaping the landscape, carving deep U-shaped valleys and forming sharp peaks. Hanging glaciers continue to supply water and sediment, maintaining a complex hydrological system. Each valley carries distinct geological signatures, from hard metamorphic rock to fine sediments accumulated over long periods. The isolated terrain preserves these natural structures with minimal external disturbance. Vegetation adapts to harsh conditions, anchoring onto cold rock surfaces and forming a clear biological boundary. North Cascades represents a balance between the stability of rock and the continuous motion of ice. Haystack Rock does not stand out because of the width of the coast, but because it stands alone in the water like a rock mass that does not belong to the present. Rising about 236 feet, this basalt sea stack appears isolated, compact, and instantly recognizable. That outline alone is enough to make it one of the strongest visual symbols of Oregon. What makes it unusual is that Haystack Rock is not a random boulder left behind by the waves. It is the remaining core of a basalt mass formed about 15 to 17 million years ago. Over time, the softer sediments around it were gradually worn away by the sea, while the hardest part remained standing like an ancient stone core from a vanished landscape. But Haystack Rock is not only geology. At low tide, a dense intertidal ecosystem appears around its base, with sea stars, sea anemones, crabs, snails, and many other organisms attached to the rock. The rock itself also serves as a nesting site for seabirds, making it both a stone landmark and a living structure. That combination is what makes Haystack Rock so rare. It is still like a monument, yet alive like a miniature biological island. A very simple shape, but one that holds both geological time and an extraordinary concentration of coastal life. Ruby Beach does not function like an ordinary leisure destination, but as an open-air geological workshop, where the Pacific Ocean directly shapes the final form of the continent. Its name is linked to grains of sand with a reddish gleam created by tiny mineral crystals, giving the beach surface a tone that feels both cold and unusual. The strongest impression here comes from the rock pillars standing apart offshore. They are not random masses of stone, but the remains of an ancient shoreline worn away by the sea over immense spans of time. The ocean removed the weaker material and left the harder cores behind, like geological markers standing alone in the water. Along the shore lie dense accumulations of driftwood, clear evidence of powerful currents and heavy water seasons. They do not only create a distinctive visual structure, but also show that this coast is still receiving, shifting, and rearranging natural material through every cycle of rough water. When the tide falls, the rock surface is exposed, along with tide pools rich in life. Ruby Beach is therefore not only beautiful to look at, but a place that clearly shows how geology, tides, and coastal organisms exist together in a landscape that is always in motion. Erosion by the hydrosphere at Silver Falls has created a rare reverse-cut rock structure where water keeps hollowing out the softer rock below and leaves the harder basalt ledges projecting above. That process formed the large recesses around the base of the falls and gave this landscape a shape that is difficult to mistake for any other. What makes Silver Falls remarkable is not only the size of the falling water, but the ability to observe the flow from behind the curtain itself. In very few places can people look through falling water and clearly see rock structure, moisture, and light operating together inside such a confined space. This entire area is the result of ancient lava eruptions that left behind clearly layered rock. When water strikes the plunge basin below, mist is forced upward, creating a cool and wet microclimate all year and allowing ferns and moss to spread densely across the rock surfaces. Silver Falls is therefore not simply a group of waterfalls. It is direct evidence of how water and stone can reshape a landscape together, where erosion does not destroy beauty, but becomes the force that creates it. White River Falls appears as a dramatic geological wonder amidst the arid grasslands, where the white waters cascade down through layered basalt rock formations. This is a multi-tiered waterfall structure with a significant total height, cutting through volcanic rock layers, exposing ancient sedimentary deposits buried for millions of years beneath the earth. The erosive power of the water has carved out a narrow, deep canyon where the moisture from the falls contrasts sharply with the arid plains surrounding it. The most remarkable feature of White River Falls is the exposure of the stratified lava flows, each rock layer representing a different volcanic era from the past. The waterfall does not just fall, but crashes powerfully against the basalt edges, creating spectacular water sprays and small pools suspended mid-air. The surrounding cliffs, with their characteristic orange and gray hues from weathered basalt, form a backdrop of formidable and ancient geology. At the base of the falls, the White River continues to carve through the smooth basalt, creating fast-flowing channels towards the Deschutes River. The remnants of an old hydroelectric station sit beside the falls, now overtaken by nature, creating a stark contrast between human civilization and the eternal force of hydrology. Standing before White River Falls is standing before the convergence of destructive power and the tectonic beauty of water over volcanic rock. The waterfall stands resilient, like an energy oasis in the wilderness, where every drop carries minerals eroded from the heart of Oregon's plateau. Here, geology showcases its complex layering, and the hydrosphere exerts its power to reshape space, creating a breathtaking survival drama of nature's motion. Multnomah Falls is a place where water appears as a vertical cut across ancient basalt, making the entire cliff look as if it has been split open by hydraulic force and time. Rising about 620 feet, this is a rare two-tier waterfall and also one of the most recognizable images in the American Northwest. What makes this place special is not only its height, but the way the water keeps such a concentrated form. Instead of spreading wide, it descends as a narrow band, continuously cutting into the rock over long periods of time. The whole landscape is also tied to the legacy of the Great Floods at the end of the Ice Age, events powerful enough to reshape many basalt layers in the region. The rock walls around the falls still carry the marks of ancient magma, with steep faces and durable stone structures that keep the flow compressed into a narrow corridor. Constant spray and high humidity have created a cool microclimate that supports dense vegetation clinging to the rock. Multnomah Falls is therefore not only a tall waterfall, it is a clear image of how water persistently acts on stone, and through that repeated force, creates a landscape that is both visually powerful and deep in natural history. Helm Falls is a place where water and cold can be seen reshaping land in a very direct way. From the edge of a basalt plateau, the water drops about 463 feet into a horseshoe-shaped plunge basin, creating one of the most powerful and unusual waterfall structures in Canada. What makes this place unusual is not only its height, but the way it keeps changing with the seasons. In winter, mist rising from the base of the falls meets extremely cold air and gradually freezes, forming a giant cone of ice that can reach about 164 feet in height. It is a temporary structure, but enough to turn the base of the falls into a rare, natural ice chamber. The dark basalt around the falls records the history of ancient lava eruptions. Over long periods of time, water has kept cutting into the rock, widening the plunge basin and driving material downward. That constant collision between water, stone, and temperature creates the harsh and distinctive force of Helm Falls. Helm Falls is therefore not only a tall waterfall, it is a place where erosion, freezing, and the power of water can all be observed at once in a landscape that is still actively unfolding. Known as the Niagara of the West, Shoshone Falls is a geological wonder formed on ancient basalt, where water plunges into a canyon from a height of about 213 feet. This landscape originated from the Bonneville Flood at the end of the Ice Age, an extreme hydrological event that rapidly carved through volcanic rock, leaving behind steep cliffs that persist today. The hexagonal basalt columns, aligned vertically along the canyon walls, are remnants of slowly cooled ancient lava. From a distance, the rock surface appears as a natural geometric network, sharply contrasting with the white cascading water. With a width of nearly 984 feet, the waterfall impresses not only in scale, but also in flow volume, continuously breaking and reshaping the rock surface. Each seasonal surge deepens erosion channels further. In the surrounding arid environment, the water flow acts as an ecological balance, sustaining moisture for vegetation clinging to the rock faces. Shoshone Falls therefore stands not just as scenery, but as evidence of long-term interaction between hydrology and geology. Toketee Falls is a masterpiece of columnar basalt structure where water cascades through a narrow fissure surrounded by nearly perfectly stacked hexagonal rock columns. These formations were created by the slow cooling of ancient lava, as hot material contracted and fractured along stable geometric planes, a fundamental principle of thermodynamics. The waterfall is divided into two distinct tiers. An upper drop of about 39 feet reduces the flow energy before the water plunges down a main fall of about 79 feet. This tiered structure reflects variations within the underlying basalt layers. The dark grey rock surface contrasts with the blue water of the pool, creating a muted palette that emphasizes the raw nature of the landscape. Light entering the narrow canyon at certain times of day highlights the sharp, angular geometry of the columns. Toketee Falls is therefore not just a waterfall, but a direct expression of physical laws governing cooling magma. Where natural geometry formed millions of years ago remains largely unchanged. Englishman River Falls emerges as a geologic masterpiece, where the Clearwater River carves through ancient basalt rock layers, cascading into a natural emerald lake below. The falls are defined not by their height, but by their multi-tiered flow structure, creating a vibrant display of white water as it tumbles down the landscape. The exposed rock layers display intricate geological folds, with smooth surfaces worn down by thousands of years of cold river water. The erosion occurs vertically and horizontally, creating smooth basins and sharp fissures in the surrounding canyon walls. Notably, the water changes color during the spring thaw, carrying minerals from the high mountain core, enriching the downstream ecosystem. The mist rising from the falls forms a permanent fog, nourishing lush mosses and ancient ferns that blanket the cold basalt rocks. Englishman River Falls is a symbol of the harmony between geology and hydrology, where the forces of nature create a perfect natural space where water and rock converge in perfect balance. Redfish Lake appears like a massive geological mirror at the foot of a majestic granite mountain range, formed by ancient glaciers during the Quaternary period. The deep lake dominates a U-shaped valley, storing cold water filtered through cracks in the granite and quartz. The surrounding mountain peaks, with sharp granite structures, are remnants of glacial erosion. These tooth-like lithosphere formations rise sharply toward the sky, showcasing the strength and persistence of natural elements over millions of years. The still waters reflect the characteristic deep green hue, while the pine forests tightly line the water's edge, creating a fragile biological boundary. Tree roots must weave through loose rocks to seek stability, overcoming the harsh winds and snow. Redfish Lake is a symbol of nature's serenity and power, where time seems to stand still amid the perfection of geography. Cape Kiwanda is where fragile sandstone lithosphere directly confronts the erosive power of the ocean, creating a constantly changing landscape. The sandstone layers here formed from ancient marine sediments, but their weak bonding makes them highly susceptible to wave and wind erosion. Golden dunes and orange rock formations are not fixed. They are continuously reshaped after each storm cycle. Sea caves and steep cliffs form and collapse, reflecting an unusually high rate of erosion. The isolated offshore rock is a remnant of an ancient coastline, marking where land once extended before being reclaimed by the sea. Each wave striking the base removes material, weakening the structure and triggering collapses. Wind continues to transport sand upward, forming steep dunes along the shoreline. Cape Kiwanda is therefore not a stable landscape, but a system undergoing constant dismantling and reconstruction under oceanic forces. Emerald Lake appears as a giant emerald block surrounded by the granite and limestone walls of the Rockies. The lake's signature green color is the result of light scattering on fine glacial rock flour, creating a surreal beauty within the deep green of the pine forests. The lake's basin is a collapsed tectonic depression formed by the movement of ancient glaciers, storing crystal-clear water rich in minerals from the surrounding mountain peaks. The stillness of the lake's surface creates a powerful visual pressure as sharp mountain peaks reflect in the water. The debris fields at the base of the mountains are evidence of ongoing erosion, continuously replenishing the lake's mineral content over centuries. The remarkable stability of the lake's color transforms it into a natural optical laboratory within ancient limestone strata. The President Mountain Range serves as a geological shield, preserving the unique microclimate inside the valley. Fallen trees on the lake's surface do not decompose, but are preserved in the cold water, creating fascinating biological structures at the bottom of the transparent lake. Emerald Lake is a testament to the delicacy of geological processes, where the harshness of glacial erosion has created a gentle masterpiece. It is not just a water reservoir, but a dynamic geographical entity where geology and hydrology converge to form a perfect balance in nature. Samuel H. Boardman State Scenic Corridor appears as a geological field where basalt masses are fragmented and isolated under constant oceanic forces. These rock structures formed from ancient lava, later uplifted and exposed before being eroded by waves over millions of years. Natural arches, sea stacks, and deep-sea caves result from mechanical erosion combined with chemical weathering. Waves not only strike the surface, but also compress air and water into fractures, increasing internal pressure and expanding the rock structure over time. Salt spray and wind accelerate weathering, while vegetation survives by anchoring roots into narrow cracks. This creates a biological boundary where life persists under minimal conditions. Offshore rock formations are remnants of an ancient coastline. The entire region reflects an ongoing process where material is detached from land and redistributed into the ocean, continuously reshaping the shoreline. Mount St. Helens stands as a geological scar of modern history, where Earth's internal forces reshaped the landscape in a single event. The 1980 eruption did not only destroy the summit, but created a horseshoe-shaped crater, exposing an active magma system beneath. The rock layers clearly record eruption cycles, from ancient lava flows to fresh ash deposits, forming a continuous geological archive. Inside the crater, glaciers have formed under unusual conditions, existing above zones still releasing geothermal heat. A new hydrological system is developing as rainwater and meltwater erode weak pumice, carving drainage channels that did not exist before. The terrain continues to evolve beyond the initial eruption. Biological recovery progresses slowly but steadily, with pioneer species adapting to harsh conditions. Mount St. Helens represents both immediate destruction and long-term regeneration. Mount Baker is not merely an ice-covered peak. It is an active stratovolcano where glacial mass and internal heat exist in a fragile balance. With some of the highest annual snowfall in the region, layers of snow continuously compress into dense glacial ice, concealing an underlying magma system that remains quietly active. Its andesite structure is carved by hanging glaciers and deep fissures, forming terrain that is both majestic and hazardous. Geothermal vents near the summit release mineral-rich steam, creating unusual ice caves where heat and cold intersect within confined spaces. Historically, the area has shown repeated geothermal unrest, indicating the volcano is far from dormant. Sudden increases in heat can generate destructive mud flows capable of reshaping entire landscapes. What appears static is in constant transformation as glaciers erode the surface while simultaneously acting as a heavy shell that restrains immense internal energy, an ongoing natural system in motion. Diablo Lake draws attention with its surreal emerald color, an optical phenomenon formed by ultrafine rock flour ground by glaciers and carried downstream. These suspended particles scatter sunlight, producing a rare hue that directly reflects intense glacial erosion processes. The basin itself is a glacially carved valley, later filled with water as the climate warmed. Surrounding granite and basalt formations display ancient fractures, recording millions of years of tectonic pressure and movement. In modern times, the area has become a center of hydroelectric development, where water flow is controlled, but the mineral composition remains unchanged. Continuous inflow of sediment preserves the lake's distinct color year-round. More than a landscape, the lake is an active geochemical system where light, minerals, and glacial dynamics combine into a visible expression of ongoing geological processes. Cape Lookout rises like a colossal sword, extending nearly 3 miles from the coastline into the Pacific Ocean. Formed from a massive lava flow millions of years ago, it serves as a natural defense against the relentless advance of the ocean. The cliffs stand over 300 feet tall, creating a striking visual pressure where the land meets the vast ocean. The narrowness and height of the rock layers are exceptional, where trade winds and ocean waves continuously crash against the stone faces. Coastal rainforests cling to the cliff edges, forming a green band contrasting with the eroded volcanic rock. Every storm brings salt-laden winds that bleach the rocks, forcing the plants to adapt to extreme survival conditions. Below the cliffs, sea caves and eroded rock holes provide further evidence of the ocean's relentless pursuit of the land. Cape Lookout stands as a timeless symbol of geological resilience, where the earth meets the sea with unyielding force. Liberty Bell Mountain stands as a monolithic granite tower with near-vertical rock faces that clearly reflect its origin as an intrusive magma body deep within the earth. This rock mass cooled under high pressure before being uplifted and exposed through millions of years of erosion, resulting in an exceptionally stable structure. Its bell-like shape is not accidental, but the result of selective erosion, where glaciers removed weaker material while the dense granite preserved sharp edges. Vertical fractures formed as overlying rock layers were stripped away, releasing pressure. The smooth, steep rock surfaces resist chemical weathering, while freeze-thaw processes dominate physical breakdown, producing rockfall that accumulates at the base. Despite harsh conditions, vegetation survives within narrow cracks. Liberty Bell represents a balance between the strength of granite and the slow but persistent forces of environmental erosion. Palouse Falls appears as a sudden geological incision across a dry basalt plateau, where modern water flows through a landscape shaped by massive Ice Age floods. Ancient megafloods violently eroded basalt layers, forming a deep canyon and a nearly perfectly shaped plunge basin. Stacked lava flows are clearly exposed along the cliffs, revealing repeated eruptions and rapid cooling of molten magma that created distinctive polygonal basalt columns. The geological structure here records not only volcanic activity, but also extreme erosion occurring over very short periods. The waterfall drops about 197 feet into a deep basin surrounded by steep rock walls, generating powerful kinetic energy that continues to carve into the bedrock. Its unusual isolation in a vast plain shows how the river has preserved its ancient course despite major environmental changes. Palouse Falls stands as a rare testament to the combined power of hydrosphere and lithosphere, where brief but catastrophic events permanently reshaped the Earth's surface into a lasting geological legacy. Ecola Falls appears from a deep, horseshoe-shaped canyon, where the waterfall bursts directly from a narrow basalt crack, plunging into the crystal-clear rock pool below. This waterfall features characteristic flow dynamics, with a smaller waterfall above, creating significant hydraulic pressure before channeling all the energy into the main drop, which is 351 feet tall. The cliffs surrounding the waterfall are made of giant basalt columns, remnants of ancient lava flows that ran through the canyon millions of years ago. Erosion has formed caves behind the waterfall curtain, where moisture-loving plants take root in the rock fissures to survive. The lake below accumulates large boulders, dislodged from the cliffs through centuries of erosion, creating a geological puzzle at the bottom of the water. With every flood season, the flow restructures the canyon's landscape. Ecola Falls is a testament to the powerful intersection of volcanic lithosphere and hydrology, where nature's force creates a raw, majestic environment. Snoqualmie Falls is a hydrological system where the river plunges approximately 269 feet into a deep gorge, cutting through ancient basalt formed from cooled lava flows. The geological structure reflects the durability of compressed volcanic rock, allowing the cliff to maintain its form over long periods. The falling water generates high pressure at the base, continuously smoothing rock surfaces and reshaping the lower layers. Mist rising from the impact creates a humid microclimate that supports moss and fern ecosystems on steep rock faces. Water flow varies significantly by season, with snowmelt and rainfall increasing discharge and altering the waterfall's intensity. This results in uneven erosion patterns influenced by climate cycles. Snoqualmie Falls is therefore not just a waterfall, but a point of interaction between hydrological energy and geological structure, where water continuously reshapes the terrain. The Joffre Lakes system appears as a series of glacial terraces filled with emerald water, where color is not an aesthetic feature, but a direct result of rock being ground under immense pressure from moving ice over millennia. Ultrafine rock flour remains suspended in the water, scattering light and creating the distinctive blue-green hue. This serves as an optical indicator reflecting the intensity of upstream erosion, where glaciers have powerfully affected the lithosphere. The lakes were formed in depressions carved deeply by glaciers during the last ice age, creating a distinct stepped structure. Each lake functions as an independent sediment reservoir, recording cycles of melting and material transport over thousands of years. Water is continuously supplied by hanging glaciers, carrying minerals and maintaining stable temperatures, sustaining the surrounding ecosystems. Surrounding debris fields are not only remnants of landslides, but also act as natural barriers that regulate water flow and trap sediment. The entire system operates as a dynamic geological hydrological network, where ice, rock, and water interact continuously, maintaining a state of balance that is difficult to find in high-altitude environments. Cape Flattery stands as the terminus of the continent, a geologic battlefield where islands and sea caves are carved by the unyielding power of the Pacific Ocean. The ancient basalt strata here have been overtaken by the ocean, creating natural stone bridges and deep fissures that the waves continuously crash into. The towering cliffs, covered in a perpetual mist, create an ethereal space where seabirds cling to the jagged rocks amidst the roar of the waves. What sets this place apart is the vivid turquoise water, contrasting sharply with the dark grey basalt, creating a surreal visual effect. The ocean currents collide around the isolated sea stacks, generating powerful whirlpools capable of crushing anything in their path. The geological history of this place records the tectonic shifts that pushed ancient layers of rock to the surface, facing the relentless force of the ocean. Cape Flattery is where geology and hydrology intersect, creating a powerful and fierce environment, symbolizing the endurance of nature. Takakkaw Falls appears as a majestic white ribbon cascading from the peaks of the Rockies, with one of the largest freefall drops in North America at 1,224 feet. Its source is the Daly Glacier, nestled deep in the highlands, feeding the falls with cold, mineral-rich water. The most dramatic moment occurs when the water bursts out from the granite cliff before plunging straight down, creating an overwhelming hydrodynamic effect. The fall's power lies in the combination of breathtaking height and the extreme air pressure at its base, generating a mist that covers the entire valley. The surrounding sedimentary rocks reveal complex geological folds, recording the uplift of the mountain range from the ancient seabed hundreds of millions of years ago. Water erosion here is slow but persistent, carving deep grooves into the granite rock. In summer, when the glaciers melt most intensely, the roar of Takakkaw echoes throughout the wilderness, carrying the immense energy of the frozen peaks. The white water contrasts sharply with the dark green of the pine forests and the gray of the rock, forming a visually oppressive masterpiece. Takakkaw Falls is the embodiment of pure gravitational force, where every drop of water carries the energy of the highest peaks. The name of the falls in ancient language means astonishment, and indeed, this waterfall is worthy of such a description, a living, natural wonder that constantly reshapes the space and the sound of the vast mountain valley. Pacific Rim is a geological battlefield where the ocean and ancient forests clash incessantly along the island coastline. The region's geology is dominated by metamorphic rock and ancient basalt, shaped by relentless waves into sharp rock formations and expansive tidal flats. This is a boundary of extremes where oceanic moisture envelops towering cedar trees rooted in rocky outcrops near the water's edge. What sets the region apart are the tidal flats, where receding water unveils sinkholes, revealing resilient, miniature ecosystems thriving in the harsh environment. The constant interaction between geology, hydrology, and atmosphere blurs the lines of this mysterious landscape, where everything continuously changes. Pacific Rim stands as a testament to the raw power of nature and the endurance of life. Joffre Falls is a monumental waterfall where the river cascades down a massive basalt platform from a height of 230 feet. This waterfall generates powerful hydrodynamic forces that reverberate through the surrounding rock structures. The erosion here does not form deep gorges, but instead expands horizontally, creating a sweeping white arc nearly 300 feet long. Mist rises from the base of the falls, creating a constant fog that blurs the boundary between the limestone strata and the raging water. Fallen rocks and decayed tree trunks accumulate at the foot of the waterfall, testifying to the destructive power of the river during flood seasons. The waterfall's unique stepped formation is due to the water's impact with the rocky ledges, creating dramatic foam cascades. The gorge below holds geological remnants, offering evidence of thousands of years of glacial flow through the land's crust. Wildest Falls stands as a symbol of the power and resilience of the hydrosphere, where water continuously reshapes the landscape.
A cascata Salt Creek ergue-se como uma característica geológica monumental, onde o rio cai 87 metros em uma antiga bacia de basalto. A erosão aqui não cria gargantas profundas, mas se expande horizontalmente, criando um arco branco dramático de quase 100 metros de largura. A névoa que sobe da base da cascata forma uma cortina constante, desfocando a fronteira entre as camadas de calcário e a água turbulenta. Os penhascos ao redor revelam formações de colunas de basalto, mostrando o processo de resfriamento do magma de erupções vulcânicas que ocorreram há milhões de anos. A aparência única da cascata é acentuada pela espuma gerada quando a água cai sobre as rochas, criando contrastes visuais dramáticos. O fundo da bacia acumula detritos da erosão de séculos, criando uma escada de pedras natural para o próximo fluxo de água. A cascata Salt Creek é um símbolo de resiliência e poder, onde a natureza continuamente remodela a paisagem através do fluxo implacável da água.
Nooksack Falls appears as a deep incision into the rock structure, where the river of the same name is forced through a narrow crack before plunging into the abyss. This is a highly dramatic waterfall, surrounded by steep granite cliffs that form a crushing geological bowl, shrouded in mist from the powerful water spray. The flow's energy is concentrated in a single drop, generating hydrodynamic force strong enough to crush even the largest boulders swept by the floodwaters. The basalt at the cliff faces shows intense weathering from the constant humidity and water vapor, with thick moss covering the cold gray rock. What makes Nooksack Falls so unique is the steepness and narrowness of the canyon, amplifying the roar of the falling water, creating a deep, resonating sound unlike any other waterfall in the region. Each cubic meter of water falling not only carries kinetic energy, but also releases enormous pressure into the confined space, generating cold, glacial winds. The geological history of the falls is tied to the violent tectonic movements that lifted the Cascades, forcing the river system to carve its way through volcanic rock. The fissures in the strata are the result of material contraction as the magma cooled, now serving as powerful natural water channels. Standing before Nooksack Falls is standing before the raw force of nature, where the hydrosphere and lithosphere engage in an unrelenting battle. The falls stand as a reminder of water's power to both destroy and rebuild, a dynamic force that shapes the wild landscape. Upper Mesa Falls appears as a grand waterfall spanning the entire width of the river. The powerful waterfall crashes over a massive basalt platform formed from an ancient supervolcano eruption. This is the only waterfall in the region untouched by human construction, retaining its pristine, layered rock structure. The cliffs rise like a 10-story building, creating a majestic scene. The basalt layers surrounding the waterfall date back over 1 million years, a relic of the ancient volcanic eruption. The volcanic rock is compacted, highly resistant to hydraulic erosion. The color of the cliffs changes from reddish-brown to dark black, depending on the moisture in the steam rising from the waterfall. The vertical cracks in the basalt form a perfect geometric structure, showcasing the enormous geological forces that shaped the plateau. Beneath the waterfall, a basin of glass and rubble has accumulated over centuries. The powerful water flow has created a unique microclimate, nurturing vibrant, deciduous trees that thrive in the otherwise barren basalt landscape. Each splash of water carries significant hydrodynamic energy, creating cold air currents that flow from deep within the canyon, regulating the temperature of the surrounding forest. Upper Mesa Falls is not only a symbol of natural beauty, but also a living geological archive, where the waters and basalt stones continue to tell the story of time and nature's perseverance. Myra Falls is a multi-tiered hydrological masterpiece where the Clearwater River winds over basalt rock shelves before tumbling into a pristine emerald green lake below. This waterfall's dynamism is not defined by height, but by its multi-layered flow structure, creating white frothy waves that spread out like the mane of a galloping horse across the wilderness. The exposed strata here show intricate geological folds, with the smooth surfaces of rocks worn down by thousands of years of cold river flow. Erosion occurs both vertically and horizontally, creating smooth rock basins and sharp cracks within the surrounding canyon walls. Notably, the water changes color during the spring thaw, carrying minerals from the high mountain core, enriching the downstream ecosystem. The mist rising from the falls forms a permanent fog, nurturing lush mosses and ancient ferns which blanket the cold basalt rocks. Myra Falls represents the harmony between natural processes, where geology and hydrology intertwine, creating a unique biological space where water and rock meld into nature's perfect design. Lower Mesa Falls appears as a deep incision into the rock structure, where the river winds through basalt terraces before plunging into a deep gorge. Unlike free-falling waterfalls, this one demonstrates the power of horizontal erosion, creating rapids and foam across the valley. The basalt layers here are carved over thousands of years by water that tirelessly seeks out the smallest tectonic cracks to erode. The surrounding cliffs, though lower in height, bear a rough and wild beauty, with volcanic ash deposits exposed on the eroded surface. What makes Lower Mesa Falls unique is its dispersed flow pattern, where water weaves through narrow rock crevices before converging into a powerful cascade. The contrast between the green of the pine forest and the gray of the volcanic rock creates a cinematic space, showcasing the continuous transformation of the landscape. Lower Mesa Falls stands as a testament to the persistence of natural processes, where water is not just a flow, but a part of the rock architecture itself. Cape Disappointment rises like an extreme outpost where the mighty river collides head-on with the raging force of the Pacific Ocean. This is the most dangerous body of water in the world, where the river and sea battle it out on shifting sandbars and towering cliffs, creating a graveyard of sunken ships beneath the turbulent waves. The basalt formations here are the remnants of ancient lava flows, now standing as final fortresses against the relentless erosion of the ocean. The cliffs surrounding Cape Disappointment are towering, subjected to powerful trade winds and thick fog year-round, creating a visually oppressive and mysterious space. What's unique is the ever-changing coastline, where waves can reach heights of tens of feet, crashing into the basalt cracks and creating massive water explosions audible from afar. The coastal rainforests stand resilient on top of the jagged cliffs, where the wind bends the trees into strange shapes, a testament to the harsh survival of life in this environment. A small geological basin is filled with enormous driftwood, battered and crushed by the ocean. The contrast between the white lighthouse on the black cliffs and the cold, gray sky symbolizes the human perseverance against nature's fury. Every cubic meter of basalt at Cape Disappointment is weathered by salt and sculpted by tides, constantly changing the structure of the land extending into the sea. Standing at Cape Disappointment is standing at the ultimate boundary of the continent, where geology, hydrology, and meteorology converge in a grand conflict. This is not just a geographical landmark, but a dynamic, tragic, and powerful geological entity, where every wave is a strike against the eternal basalt layers. Bridal Veil Falls operates as a massive hydrological grid, where the water must spread across a smooth stone surface before cascading down from a height of 197 feet. The cracks in the sedimentary rock do not create free falls, but force the water to slide, creating a ribbon of white silk. Below the waterfall, the basalt strata demonstrate the persistent erosion of nature. The water does not deeply erode, but expands the area of contact, forming a mist that covers the giant fir and cedar trees. Each cubic meter of water spilling across the stone's surface carries gentle but persistent hydrokinetic energy, smoothing the sharp edges of the volcanic lithosphere. This process does not destroy, but creates landscapes that are soft yet powerful. At Bridal Veil Falls, petrology and hydrology blend into a unique flow structure, showcasing the finesse of nature through each droplet of water, each cut of rock. The Wallace Falls system is a complex, terraced geological structure where the river is forced through narrow canyons before plunging over 3 levels of granite and metamorphic rock. With a slope of over 150 meters, the water creates a powerful hydrological surge, cutting through the Earth's crust and revealing the scars of the ancient Cascade mountain range. Each tier of the falls represents a different stage of erosion, as water exploits the weaknesses in the tough rock structure, altering the flow over time. The mist rising from the canyon helps sustain a temperate rainforest ecosystem, with mosses clinging to the steep rock walls, forming a biological barrier. The middle tier is particularly striking, where water crashes into a basalt basin, generating icy gusts of wind, a clear sign of the immense tectonic pressure. These giant rock slabs are pushed upward, forcing the water through sharp cracks. Wallace Falls stands as a living testament to nature's resilience, where the combination of geology and hydrology continues to shape and redefine the landscape through relentless erosion. Trillium Lake appears as a perfect geological mirror, where the calm surface of the water stores meltwater under the shadow of a massive volcano. This is a geologic basin formed on the foundation of ancient swamps, where highland hydrology meets the volcanic basalt crust. The lake's distinguishing feature is its remarkable symmetry, where the snow-capped peak is perfectly reflected, creating a surreal visual effect, blending the sky and the earth as one. The surrounding fir forests line the shores, highlighting the white of the glaciers and the gray of the volcanic strata. The lake bed not only stores thermal energy, but also regulates the flow from the cold peaks, maintaining the downstream ecosystem. The calmness of the lake contrasts with the subtle geothermal activity within the heart of the mountain, creating a fragile balance between the stillness of the water and the movement of fire. Trillium Lake is a symbol of nature's tranquility, where geology and hydrology converge, affirming the beauty of stillness in a world of dynamic geologic forces. Toketee Falls operates like a wall of white energy on the Mackenzie River, where the flow is forced over a vast basalt shelf from a height of 69 feet. Formed by ancient volcanic eruptions, the falls are the result of hydraulic erosion, creating an impressive scale geological sinkhole. The basalt layers here reveal tightly compressed lava flows, capable of withstanding the massive impact of thousands of cubic feet of water falling each second. The emerald green color of the lake beneath the falls is a testament to the pure water, enriched with minerals from the volcanic lithosphere. What's remarkable about the falls is its perfect arc structure, where water flows evenly across the rocky edge instead of falling in a single drop. The water mist rising from the base creates rainbow arcs suspended between the forest canopy, softening the harshness of the gray basalt cliffs. Coosa Falls is an essential part of the Cascades hydrological system, where water continues to carve the riverbed and assert the strength of natural forces. The Columbia River Gorge is a grand geological cut through a long mountain range, where the river has relentlessly carved through basalt layers over millions of years, linking the inland to the ocean. This is a natural geological laboratory where layers of lava flow stack up hundreds of feet high, a testament to the violent volcanic eruptions in Earth's history. The power of the gorge lies in the combination of tectonic uplift and extreme hydraulic erosion. Notably, the Missoula floods tore the rock surface apart like layers of paper. The steep cliffs surrounding the river are home to dozens of hanging waterfalls, creating a complex hydrological system. Trade winds blow into the narrow gaps of the gorge, creating strong atmospheric pressure, regulating temperature, and forming unique microclimates for plants to cling to the cliffs. This gorge is an eternal, natural fortress where geology and hydrology intersect, showcasing the continuous transformation under the flow of water. Cape Arago is a geological outpost where sedimentary rock shelves are tilted and cut by the relentless power of the Pacific Ocean. The lithosphere here showcases deformation through layered rocks, once part of ancient seabeds, uplifted by intense tectonic activity in the coastal region. The The steep cliffs here endure tremendous hydraulic pressure from the ocean's waves, forming caves and smoothened basalt hollows. What makes this area special is the submerged reefs and small offshore islands where ocean currents are forced to twist, creating dangerous whirlpools and deep sounds from the sea's depths. The tidal ecosystem clings to the sharp rocks, facing extreme fluctuations in salinity and temperature with each tide cycle. Coastal rainforests shade the gray cliffs, creating a stark contrast between the wild forests and the raging ocean. Cape Arago is an eternal geological battleground where land continually retreats before the power of the ocean, documenting the shifting sea levels and the forces reshaping the oceanic space. Whitehorse Falls emerges as a delicate, tiered masterpiece where the Clearwater River winds through basalt ledges before plunging into a turquoise, natural lake. This waterfall isn't defined by its height, but by its multi-tiered flow structure, creating white, frothy ribbons that resemble a warhorse's mane galloping across the wild expanse. The surrounding rock layers reveal smooth, weathered volcanic rocks, a testament to the persistence of hydrology as it carves through the rough edges of the region's geology. The mist, rising from the falls, blankets the moss-covered ground, sustaining moisture-loving plants that flourish in the sheltered valley. What stands out here is the surrounding stillness, where the soft sound of flowing water and the deep green of the forest combine to form a graceful geographical entity. Small depressions at the base of the falls mark the evidence of erosion over centuries. Whitehorse Falls embodies the perfect balance between the flow's power and the volcanic rock's stability, reminding us of the subtle yet captivating geological details nature provides. Cape Meares stands like a basalt fortress towering over the Pacific Ocean, formed by colossal lava flows from 15 million years ago. The basalt cliffs rise over 200 feet, acting as a sturdy shield against the relentless erosion from ocean waves and coastal trade winds. What's unique here is the hollowed geological structure, creating mysterious sea caves and solitary sea stacks offshore, remnants of a long-lost continent. Coastal spruce trees cling to the clifftops, bending under the pressure of fierce winds, creating a biological boundary between land and sea. At the foot of the cliffs, the ocean waves crash into the geological cracks, generating massive bursts of water mist and thunderous sounds echoing through the black basalt cavities. Cape Meares stands as a symbol of geological power, where volcanic geology demonstrates its absolute toughness in protecting the land, offering a strong visual space and a constant survival narrative.